Hi everyone, welcome back to Lulumath. This video is on how to check solutions in equations, and you'll need to know how to solve equations in order to be able to check solutions. So we need to know how to solve multi-step equations as well as solve equations with fractions. There are videos on both of these topics at lulumath.com as well as the Lulumath YouTube channel if you would like a refresher on this information. Now, a really important note is that checks must always be done in the original equation. And I'll talk about this more in depth after we talk about how to do our first check. I'll explain to you why it has to be done in the original equation. So we want to check the solution in the following equations. And our first equation is 5x minus 9 equals 2x plus 15. And we actually solved this equation in the video on solving equations with variables on both sides. So here is our equation and here is our solution, and we ended up getting x equals 8. So we're going to check the answer x equals 8 in this equation. And the way we do that is by substituting 8 in every time we see an x to see, is this a true equation? Is this an equation that actually works? So I will start by rewriting my equation. So 5x minus 9 equals 2x plus 15. And every time I see an x, I'm going to replace it with 8. And now I'm going to follow order of operations to help me evaluate each side. So depending on your region, you might use PEMDAS or you might use BEDMAS. The first thing that we have are parentheses or brackets. And although we see brackets here, but what we mean by parentheses or brackets is to simplify any expressions that might be inside of our parentheses and our brackets. And since we only have the number 8 in our parentheses here, there's nothing to simplify. So we are done with our parentheses or our brackets. E is for exponents. There are no exponents to evaluate. M and D are multiplication and division, and we do whichever we see first. In this example, there is only multiplication, so we can go ahead and do our multiplication. So 5 times 8 is 40, and then I'll copy down this minus 9. And then 2 times 8 is 16, and then I'll copy down this plus 15. And that's it for multiplication and division. So now we're going to look and see if there's any addition or subtraction, and we can go ahead and do that. Notice how on every single line I'm copying down whatever piece I have not evaluated, because I need to make sure that each line is equivalent to the line above it. So now when I do 40 minus 9, I get 31. And when I do 16 plus 15, I also end up getting 31. So this ends up being a true statement. My two sides are equal to each other. This means that 8 is the correct answer because my two sides of my equation are equal to each other, so my equation is a true statement. So the solution x equals 8 is correct because it results in a true equation. Now, something I want you to be aware of is when we were evaluating each side of my equation, I did not move anything from the left side to the right side or from the right side to the left side. I did not use inverse operations. Because I'm not solving an equation, I'm just evaluating the two sides of my equation to see if it's a true equation or not. Sometimes you'll see it this way, where you'll see both sides of your equation as you're doing your check. And other times you'll see it with a left side, right side check. And let's talk about what that's going to look like. Now, to be honest, the left side, right side check is going to be almost identical to what we do here, but I just want to expose you to both different ways that you might see it, depending on, again, your region as well as your preference. So the left side of my equation is this 5x minus 9. So I'm going to copy that down, 5x minus 9. And because I'm checking the answer 8 in the solution, I'm going to write down 5 times 8 minus 9. And then I'll use order of operations to evaluate. So just like we did before, 5 times 8 is 40, copy down this minus 9, and then 40 minus 9 is equal to, when I do my subtraction, 31. So the left side of my equation simplifies to 31 when I'm evaluating the number 8. Now let's do the right side. So the right side of my equation is this 2x plus 15. And again, every time I see an x, I'm going to replace it with this 8. And when I multiply 2 times 8, I get 16. And then 16 plus 15, when I evaluate that, will give me 31. Since the left side and the right side both end up with equal results, x equals 8 is the correct solution. Now I'd like to revisit what we wrote here. Checks must always be done in the original equation. So let's say, for example, I had an equation that said 5 times x minus 10 equals 25, okay? And let's say I go through, I solve it. I know that I have to distribute this 5 through here. When I distribute it, I get 5x, and then I accidentally forget to distribute the 5 to the negative 10. So let's say it's 5x minus 10 equals 25. Now to solve it, I would add the 10 to both sides, so I would get 5x equals 35, so then I would end up getting x equals 7. Now, let's say, because a lot of people will accidentally do this, but let's say I want to do my check and I check this 7, this x equals 7 right here in this line right here. So I would get 5 times, and then I'll fill in a 7 here because that's what we got for x, and then minus 10 equals 25, and then 5 times 7 is 35. Minus 10 equals 25, and then 35 minus 10 is 25, so 25 equals 25. I get that I solved it correctly, but here's the thing. I solved it correctly after my initial incorrect step. So here I have no idea that I made a mistake because it checks. However, if I were to check it in the original equation, like we said we want to do, then I would have 5 multiplied by the quantity x minus 10 equals 25. So I would do 5 multiplied by the 7 minus 10 equals 25. And then when I evaluate my brackets or my parentheses first, 7 minus 10 is negative 3. So I would get 5 times negative 3 equals 25. And 5 times negative 3 is negative 15. And negative 15 is not equal to 25. So by checking in the original equation, I found that x equals 7 is not a correct solution. And that's why it's so important that we check in the original equation, okay? In our next and last check that we're going to do here, I'm going to check an equation that we solved in the Solving Equations with Fractions video. And here is our solution. It's all solved right in front of us here. And we ended up getting this x equals negative 3. So every time I see an x, I'm going to replace it with negative 3. So again, I have to follow order of operations and I have to keep everything on the side that it was originally on. So no inverse operations. I'm not moving anything from one side to the other side, okay? So I always do my parentheses or my brackets first if there's anything for me to do. And there definitely is something for me to do. So if I look here on the left side, inside of my brackets or my parentheses here, I have multiplication and I have addition. And I follow order of operations inside of my brackets as well. So because multiplication comes before addition, I'm going to multiply this 9 by negative 3. So 9 times negative 3 is negative 27. Make sure that you copy the rest of the equation down. And I'm not evaluating the brackets or the parentheses on the right side yet because I'm going to do the addition together in the same step. So here we have negative 27 plus 7, and here we have negative 3 plus 33. So negative 27 plus 7 is negative 20, and negative 3 plus 33 is positive 30. And then I'm going to copy the rest of the equation down. Now this is negative 20 over 1, and this is 30 over 1. So I'm going to go ahead and do my simplification. So here I can see 4 and negative 20 both have numbers in common. They're both divisible by 4. So 4 divided by 4 is 1, and negative 20 divided by 4 is negative 5. So then I have 3 multiplied by negative 5 left, and 1 multiplied by 1 left in the denominator, but I don't really need to worry about those ones, because anything divided by 1 is itself. So 3 times negative 5 is negative 15. Now on the other side, I have 2 and 30, and they're both divisible by 2. So 2 divided by 2 is 1, and 30 divided by 2 is 15. So here I have negative 1 multiplied by 15 over 1 times 1. I don't really need to worry about that 1 times 1. And negative 1 times 15 is negative 15, so it checks. So I know that x equals negative 3 is the correct solution. And that's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can also find blank or completed notes for this video. If you found this video to be useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.